Welcome and thank you everyone for taking the time to join us today and learn about modern practices for testing environments. I'm going to be your host. My name is Greg Duca. I'm a developer advocate at Bunnyshell. And Bunnyshell is a environment as a service platform. And today I'm joined by Mahmoud Abdel Wahab. I hope I'm pronouncing your name correctly.
Yes.
Who's a dev advocate at Neon, a very cool serverless Postgres database service. Welcome, Mahmoud. Great to have you.
Thank you for having me. I'm excited to be here.
Yes, definitely. We scheduled this session for 45 minutes. You don't need to follow all the steps that we're doing here in the demo. You can just enjoy the session, grab a drink. This webinar will be recorded and we'll post this on YouTube, so you can also rewatch this at any time. Feel free to ask any questions, drop them in the chat, and we'll get to them at the end of the session. All right, let me share my screen with you. I have a very long and boring presentation. Of course, I'm joking. We have a small presentation, a quick one, just to keep track of what we're showing today and to help you connect the dots on the concepts that you'll be learning along on this session. And all right, a little bit about the agenda for this webinar. High level, what you're going to be learning today. Then we're going to go through what Bunnyshell does and what Neon does, like 10,000 feet overview, very high level. And then we're going to go into the practical walkthrough where we're going to be going through deploying a sandbox environment on Kubernetes, starting from your Docker Compose files. And then the second step will be to attach a Neon Postgres database, serverless database to that environment. And lastly, we're going to be automating that environment spin up with each pull request or at specific pull request with GitHub Actions. What you will learn today is essentially deploying a Docker Compose based application onto Kubernetes using Bunnyshell. Then we're going to be using a Neon serverless database to instantly replicate a production database directly into your testing environment, which is an ephemeral environment. It's short-lived. It's only being used for the purpose of the testing process. And later, we're going to be tackling a little bit of GitHub Actions and showing you a couple of workflows that we have been developing at Bunnyshell to help you automate testing environments at pull request. And we'll be using these environments for that purpose. And by the end of the webinar, you're going to be equipped with a couple of modern practices that you can use for your team or for your projects to be able to test your applications more confidently. And another cool thing that you will see today is how to create in these environments for each branch, so that you wouldn't have to test on a staging environment. You can test isolated with each branch. So I think that's a really cool feature and a really cool practice. And a lot of teams start getting onboarded on that over the last couple of, let's just say over the last year. Going forward, I want to introduce you a little bit to Bunnyshell, very high level. I mentioned environment as a service, but I'm not sure if you know what that means. So essentially, an environment as a service platform allows you to create environments on demand and deploy them on different infrastructures. These environments are, oops, let me go back. So all these environments in Bunnyshell are based on something that's called environment as code, which is essentially all the sections of an environment are coded into an environment YAML, a Bunnyshell YAML, that Bunnyshell uses to replicate your environment on demand. So you have the same behavior every time you want to spin up an environment, be that testing environment, preview, development, whatever you use it, right? And for this specific example, I mean, generally speaking, actually, we're going to have a GitHub or GitLab or Bitbucket for your code. We're having a definition for your existing environment. It can be Docker Compose, it can be Helm chart if you're familiar with Kubernetes, or manifests. When we're talking about infrastructure, you can deploy on Kubernetes, you can attach different cloud resources using Terraform. But for this webinar, we'll be focusing on the Neon managed serverless Postgres instance. And again, all these go into this Bunnyshell YAML to be able to get a predictable environment all the time you need one. And you can spin it up with the UI. We're going to be using the UI today, but you can also use the CLI, the command line interface. You can also do it via APIs if you want to automate everything. So that's pretty cool as well, because you can interact with your environments in different ways. All right, going further, I'll pass it to you here, Mahmoud. You want to talk a little bit about Neon?
Yes, sure. So what is Neon? It's neon.tech. We do serverless Postgres. So it's like our goal is to be 100% compatible with Postgres. So whatever extensions, like anything Postgres specific, it should work on Neon. And it is serverless. So the reason that Neon is serverless is due to our architecture, where we separate storage and compute. This is very similar to something like AWS Aurora. And this architecture makes it possible to allocate resources dynamically based on demand. So if you need more compute, we can spin up more compute, or actually scale down to zero, which is very useful in the context of ephemeral. Can you just go back one second? Yeah, which is very useful in the context of ephemeral environments, because if you're coding and you're creating coding environments as part of like pull request flow, you don't want to like pay a lot for these environments, because you're using them for testing purposes. Maybe you have a pull request that's been open for a while. Like having the ability to scale down to zero just is a cost-effective solution, and it works perfectly for this use case. And since Neon automatically allocates resources based on demand, well, you get to pay for what you use. And that's the serverless nature of Neon. Now, right now, I want to just explain a high-level overview of some Neon-specific objects. Like Rig will go over kind of a demo and you'll see things in action, but just to give you a high-level conceptual overview. So next slide, please. So in terms of like the object hierarchy, like the different objects that Neon has, whenever you create an account on Neon, you'll first create a project. And you can think of a project as just a container where you will have the different resources. If you have, let's say, multiple applications, typically you would create a project for them. So it's a way for you to logically separate one project from the other. And when you create a project, you specify the Postgres version, and each project is deployed to a primary region. And that's kind of like the first thing that happens. Now, when you create a project within it, you have a Postgres cluster. And within this cluster, you can have as many databases as you want. There's no like limit, and like as many roles as you like. Now, what's special about Neon is we represent the Postgres cluster that's within a project. That's what you would typically find in any Postgres provider, is we represent it by a branch. And you can think of it the same way as your code. And in your code, you have a main branch, and then you can create branches off of that branch. And this way you can test features in isolation. Well, we're able to do this with Neon because we have our own custom storage layer. So next slide, please. So you can copy a Postgres cluster, and the way you do it is just like via creating a branch. And this branch will contain all of the data that's in the parent branch, which makes it perfect for ephemeral environments, because now you actually have a production-like environment that contains production data. And the branching is done using copy on write. So we don't actually replicate data, which makes this operation fast and cost effective. Now, one important thing that I'd like to mention is, since I mentioned that Neon separates storage and compute, for you to actually connect to a database that is in a branch, you do it via a compute endpoint. And this compute endpoint is like, EP mute rain. This is the compute endpoint ID. And when you create a branch, well, that branch will have its own compute endpoint. So that's how, that's the compute endpoint is where Postgres runs, your queries will run, and you'll be able to configure kind of the size of the compute, and it can automatically scale up or down based on your configuration. So this is just a high-level overview of Neon. So just a quick recap: it's serverless. You only pay for what you use. We separate storage and compute, which makes it possible for us to just spin resources up and down. And compute typically scales down to 0 after 5 minutes of inactivity, which is just great for ephemeral environments. So if anyone has any Neon related questions, feel free to drop them in the Q&A. Happy to answer. And yeah, now I will hand it over to Greg to kind of show in action how you can combine Neon's branching with Bunnyshell to achieve the flow that we covered at the start, where you can automatically create an environment, and then part of this environment, you create a Neon branch, and then use this branch in that environment so that you have an exact replica of your production environment.
Awesome. Thank you, Mahmoud. I'm proud to say that I figured out the chat, so you can also type in the chat now.
Nice.
All right. Yes. So let's talk about the application. The application we're going to use today is a pretty simple one. It's an API, a backend, which is Node.js, a front end, which is React, and then a Postgres database that we're initially going to deploy in a container. Okay, let's get to the Bunnyshell platform. Sorry about that. All right, so this is the Bunnyshell platform. I have a bunch of environments here that I have them running in case the demo doesn't go through. But what we're going to do now is we're going to create a new environment here. I'm going to say demo books live. Okay, and we have a lot of options. Maybe it's a little bit overwhelming, but we're just going to get started with the first and most basic, Docker Compose. Our application here, as I mentioned, has a Docker Compose in it. That is pretty simple. As I mentioned, 3 components: a backend component, a DB, which is a Postgres, and then a front end, which is React. Okay, we're going to import this into Bunnyshell, and we will deploy it on Kubernetes. So I have my Git account here. I want to choose my demo books application. I want to deploy from master branch. Okay, and then let's just continue. And now Bunnyshell does its magic. It's going to read all the components, backend, DB, frontend. What's important here is that the ports are explicitly mentioned in the Docker Compose so that Bunnyshell can see them, and it can create services in Kubernetes if you're familiar a little bit. So for the containers in Kubernetes to communicate, you need to have services, and Bunnyshell creates services based off of these ports. So we have them open, so that's good. Let's just continue. Now, essentially, Bunnyshell translated our Docker Compose into what Bunnyshell needs to be able to deploy this application. And again, this is a simple deployment, just containers, nothing else. And we have, actually, let's just create the application. We're going to go through the configuration a few moments later while the application is deploying on Kubernetes. Now, what we have here is a high-level overview of the environment. We have a few details about, we have components, we have different actions that we can use. But for now, we're just going to use a deploy, which is essentially going to deploy it on the Bunnyshell managed cluster. By the way, you can use the Bunnyshell managed cluster yourself. It's free. Bunnyshell has a free tier as well as Neon. You can test both platforms after this webinar. And we're also using the free tiers of both platforms for this webinar. Okay. Wow, that's unexpected. So let's just delete this environments because we have an issue. We have too many environments. Let's just delete this one too. We have a cap on our cluster. I was not expecting this, but let's just try again. Yep, demo guys are not with us today. Maybe just give it, okay, so we deleted one environment. Let's try again. All right, third time's a charm. Yes, it works. Okay, the error we were having was from the Bunnyshell cluster. I exceeded my free quota basically. So essentially, while the environment is being deployed, what I want to show you today in this environment is the view pipeline. This is a build and deploy pipeline for this specific environment, which essentially goes through a couple of checks. It builds the backend, it builds the front end from your code, from your code. Then it sees if the cluster has resources, and then it deploys all those images on the cluster, including the database. And then it checks that everything runs smoothly. You can see all the logs here, or I think you can also see them here. Yes. While the environment is deploying, maybe we can have a quick look at the configuration to show you what the differences are between the Docker Compose configuration and the Bunnyshell configuration. So first of all, we also have 3 components here, which are essentially the backend, the database that we have in the Docker Compose, and the frontend. Okay. Now, we imported some of the Docker Compose syntax, for example, the build section, the Docker file where Bunnyshell can find it, all the environment variables, all the ports that needed to be open and to be able to communicate different containers between one another. And then lastly, we added the host, which is essentially, it tells the Kubernetes cluster where to make this application accessible, because at the end of the deployment here, you will see that the URL for the front end will be accessible via the internet. And that's essentially the point here, because we have the development environment. And actually, let me go back to my presentation for a second, because I think I missed something here. All right. The setup that we have is essentially a development environment, which is deployed typically on our local machine as developers with Docker Compose. Me as a developer, I'm familiar with Docker Compose. And now we also have a production environment, which we're not going to talk about that much today. But essentially, the production environment has the database in Neon. We're going to assume that. I mean, it's actually the main branch of the Neon that I'm going to show you today is the production, so-called. What we're going to do today is tackle the testing environment for this purpose. And as I mentioned, we're taking Docker Compose from the development environment and putting it live somewhere to be able to share with somebody else, have better collaboration, and essentially have a testing environment that we can have somewhere live, which is almost like a production environment from an architectural standpoint. Okay. By the way, if you have any questions, drop them in the chat. Hey, Jennifer. All right, going back to the YAML. The database is pretty straightforward. Again, Docker Compose syntax. And then what kind of component is this? Bunnyshell recognizes this as a database, the name of the component, and then a couple of environment variables. And for the front end, pretty much the same. Okay, and we have an argument, which is the API host to know where to find, where to access the backend and to be able to see if what we have in the application as the host for the backend coincides with what we have the request from. And we also have volumes, but this is automatically done by Bunnyshell, so we don't have to worry about it that much. Let's see if our environment is being deployed. Check the pipeline again. All right, so almost there. We built all the containers. We're now deploying them on Kubernetes. It probably takes a couple more seconds. Okay, and we're gonna have it live. Okay. So no questions so far. By the way, here on each environment, we have multiple actions that we can use. We can change the environment variables, and we're gonna do that a little bit later. We also can clone the environment, and we can, once the environment is running, we can stop it, we can delete it, and so on and so forth. These are very useful when you wanna play with environments. For example, if you wanna redeploy something, like for example, today you finish your work, tomorrow you wanna redeploy the environment with the fresh changes to be able to work on that day. And another cool thing, actually we have the environment deployed. Another cool thing is that you can set the environment to auto stop when you don't use it anymore. For example, you can make it start at 9 a.m. in the morning and then shut it down automatically at 6 p.m. in the evening when you're going home. Now that we have the environment deployed, so everything works, let's check out the URLs and see if our application is working. So we don't have a book here. We're gonna add test book, and some description. Hopefully it will work. Yes, we see the book here. So essentially the application works. This is again a dummy environment. Now for the second part of the webinar, I hope everything makes sense, by the way, up until now. For the second part of the webinar, this is what we did today. This is what we did just now. We deployed this testing environment on Kubernetes. Now on the next step, we will replace the database container with a Neon branch, and we will have the production data from the production environment in our testing environment. By the way, if I missed something, Mahmoud, please let me know.
No, I think we're good.
We're good, yeah. All right. What we're gonna do now is we're gonna clone this environment now. I'm gonna name it demo book Neon integrated. All right. Clone environment. Perfect. Now the environment has been deployed as a draft. It's not manifested anywhere now. What we're gonna do now is essentially go to the configuration. At the same time, what I wanna show you is my Neon account. In this Neon account, I have my dashboard, which is my main database. And I can also see, do you wanna have a quick overview of this yourself, Mahmoud? Like the main things in the platform?
Sure. So right now you're looking at the Neon console. Greg has created a project called Demo Books. And here you can see a bunch of widgets. I would say if you go to the branches page on the left, you'll be able to see the different branches. You have a default main branch. This is the primary branch. And a primary branch just in Neon is for us to kind of distinguish what is kind of like the production branch, and the other technically are more like you would use them for something like ephemeral environments or other purposes. That's pretty much it. We have like a tables view. You can see all the tables in each branch. You have a SQL editor. Yeah, so here you'll see we have a books table. There's like one row in it. We have like a SQL editor where you can run some queries if you like. And that's pretty much it. And then we can create so what's cool is anything that can be done in the UI can also be done programmatically via our API. And I will share the links for the API docs in the chat. But as well, what's cool is we also have a CLI. So you can use it as part of, let's say, writing GitHub Actions or whatever CI/CD tool you're using. You can easily just install the Neon CLI and then create projects, branches, compute endpoints, all this sort of stuff. So yeah. And also
awesome.
one last thing, you can actually kind of configure. So if you're creating branches from, let's say, a GitHub action or something, you can configure the type of branch you're creating. So for example, if you want a powerful branch for production while having, something small running for ephemeral environments, well, you can actually do that, which is cool. But yeah.
Awesome. Thank you, Mahmoud. All right, so what I'm gonna do now is I need my connection details so that Bunnyshell can add a new branch for each ephemeral environment. And we're gonna get back here in a second, and we're gonna tackle the component first. So as you can see, we have the database, which is in a container. We're gonna replace this with the Neon component. So what I'll do now is I will add a new component, and I will select the Neon Serverless Postgres. It will be added automatically here. What I will need to do is just copy the Postgres host here, because I need to tell my backend application to which host to connect to. Okay, so let me just insert it here. We have a new component. All right, and then what I'll do now, I'll get back to my backend application, and then I'll add here my Postgres host. Perfect. Okay. Now all these connection details I'm not gonna be needing anymore, so I can just delete them. Actually, let's just keep them here for a second. What I wanna do now is, because my generic component, which is Neon database, has a couple of steps that it runs when it's being deployed. So when it's being deployed, it basically runs the script, which is found here in this at this link, which essentially checks if the database branch exists already for this environment based on its name. If it doesn't exist, it creates it. On the destroy step, if the database exists, if the database branch exists, it essentially deletes it, okay? And start and stop doesn't have to do anything because one of the cool things about Neon is that it has the idle, auto idle, and auto start capabilities. If you don't use it, you don't pay for it. Am I correct?
Yeah.
Yeah, awesome. So what we're gonna do now, we're gonna replace this Neon API token, Neon project ID, and Neon source branch ID, which essentially are, you can find them very quickly. For example, mine, let me go to my settings, I think. Settings, this is my project ID, okay? So I'm gonna copy that into my environment. I'm gonna have here a environment variables, which are in this environment. Okay, and we're gonna have this, we're gonna need the Neon project ID. Okay, awesome. Okay, and then we're gonna have a Neon source branch ID, which we will take from branches, I think, and we're gonna go to main, and then we have this branch ID.
Mm-hmm. Yeah, exactly.
Yes, we're using this branch ID because we're gonna be branching the main branch, which is the production one, right? So we use this one to branch off of. And what we'll do here, you can also find this in the documentation, but I'm doing it here as we speak. Env vars, which essentially is a way to use these variables that I'm defining here. Okay, and then the same thing for the Neon project ID. Oops. Perfect. I believe we're getting a little bit over time here, so I'm gonna try to be very brief.
I think you need to do env.vars for the project ID as well.
Correct. Yes. And the same thing for the token, but the token, I'll show you something. Open a new tab. Let me go to my environments. So at a higher level from the environments, we have the project. And we're gonna talk about the demo project here. What we wanna do here, if we're gonna use this project for these environments, actually, let me go here and the Neon integrated, I'm gonna go to environment variables, and you will see that I have a couple of environments here. Why do I have this? Because I define them at the project level, okay? And the way to define them, it's pretty simple. Add a variable here, name it, whatever you wanna name it here, give it a value, and then pass it as a secret, okay? And then just create a variable. These are all secrets. So this is my Neon API token. I believe we use it from the roles, I think, right?
No, so it's in the your user settings, like at the bottom, Greg.
Greg, okay.
Yeah, account, yeah, from your account settings, developer settings, right. And then you can generate a new API key.
Yes, so you can just generate a new one, Bunnyshell webinar, create. Okay.
So this is a secret. Please, no one don't steal it.
Yeah.
Yeah.
We can copy this one to the environment variables here. We're not gonna do it because it already works, but you get the gist of it, right? I'm gonna go back to my environment. So we have the token already defined in the project variables. We're just gonna call it here. So we're gonna use again env.vars.neon API token, and just like that. All right, I don't think anything else is missing. Okay, I need to do something else. I'm gonna change my branch here because I have a different connection. I have a different connection logic in my application on this branch. And I'll show you why in a second. So when you're connecting to Neon database, you have a pretty different way than the normal one. I would say it's not very different, but it's different from my container one, which is essentially my local host database. So here we have to use different hosts, a different endpoint, and so on and so forth. And I have those coded in my application on a different branch. So I changed that branch from application to be able to work with the Neon database. All right. And now because we have this component, the new component, we're just going to delete the database component. Sorry, the previous one, the container one. All right. Save changes. All right. Postgres host. Yes, and we also need to delete these ones because we have them in the project variables. If you remember, we have them here already inputted, already input from the, you have the Neon DB here, you have the role, which is the user here, and you can also see them with the PSQL here. I think that's right, yeah. No, Node.js. So database user password, you can also see it with the PSQL here. Really simple. It's a really easy to use interface with Neon. I really love that. And the endpoint as well. Okay, so we're gonna delete them from here. We don't need them anymore. We're gonna use the real database now. Okay, save changes again. Looks like it works. Let's just deploy them. Okay, perfect. So this is queued. All right. Now, if I want to use the other environment, I'm gonna have to delete this one because I'm already maxing out my capacity on the cluster again. View pipeline. We added a new step here in the deploy components, which is the deploy Neon database, which essentially runs the script to create a new branch in my Neon Neon project, and we're going to be using it in a second. So essentially, in my Neon main branch, I want to show you so the branches are the main. Bunnyshell is going to create a new one here, and we're going to be using the tables. So in my production database, I have the books table and I have the title Art Vendelay. So we essentially deleted the database component, which was running in a container, and we replaced that with a Neon data branch that is going to be spin up automatically using our script from the Neon database component. Maybe in the meantime, so that we can be in time, maybe I can briefly go through the GitHub Actions, which is essentially the last step. And then we're not going to get too deep into this. We're going to talk a little bit about the way we use GitHub Actions. So what I have here in my repo is essentially on the master one. Okay, perfect. Now you can see I have a couple of workflows in my folder github-workflows, which are essentially, the first one is preparing my configuration file. Okay, we have the prepare configuration and the deploy environment. We have them split up in two workflows because the way GitHub works is it doesn't allow you, if you're using public forks, it doesn't allow you to access secrets while you're pulling out the code from your code base. So we essentially pull the code in this step and we prepare the Bunnyshell YAML here in the prepare configuration step. And then in the deploy environment, we have a little bit more logic that essentially loads the artifact that we built, the Bunnyshell YAML that we built previously, and unzips it and essentially passes it over to our Bunnyshell workflow, okay, which uses it to deploy the environment and comment on the pull request. And we're going to do that just now. I think I have a pull request open. By the way, I think these are pretty straightforward. I'm going to drop you the link to this branch, into this repo. You can just copy paste them into your project. They're going to work like they're really standard. They're just going to work. They should be working in your project. And if they don't work, just feel free to message us, me especially, and I'll be able to help you with debugging this. So essentially, let's have a pull request here. There's no open pull request. We have a closed one. Just gonna open this one again. Reopen this pull request. And we're gonna have a couple of checks that will run now that are coming from my prepare and from my deploy environment. And they're also gonna check for this specific pull request if there is any environment that's already been deployed. All right. While this happens, I'm gonna go back to the Neon database environment, which hopefully was deployed. Yes, it was successfully. So that's great. Hey. Let's go back and test it. Yes. All right. Let's test how it works. All right, it works. So we have the Art Vandelay book that comes from our production database. If you remember, I showed it here. We have the main branch, which is the Art Vandelay, the architect here, the book. It's already present in this table, but we were working on a different branch, which is this one, BNS USF, blah, 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 which is the only one active. And the parent is the main branch, which is essentially our production branch. So we're working on a branch that is spin off from production, and it has all the production data in it. So essentially, that's how you have production data in your test environments. Now let's go back to our little application here, and let's just say Benny Packer Industrialist. Some description. All right, let's just add this book here. And now we have two books in our testing environment. But if I go back to my Neon console, I want to see the tables, and I want to see my table for the main branch. The main branch is the same. Okay, it didn't change in any way. The changes are only reflected in my test branch. Okay, so we have two records here. Of course, this is a very small scale, but you can go crazy with this essentially. And if you noticed, it didn't take a very long. It took very small time to replicate this database. Of course, it's very small as well, but it took a very small amount of time to replicate this. And this is thanks to the way Neon handles the storage for their database. It's a pretty advanced.
Yeah, like it actually doesn't matter the size of the database because we don't actually replicate. We use copy on write. So just some pointer magic where we point, when someone creates a new branch, we just point it to, we point the compute endpoint to the same storage. So that's why we're not replicating any data, but we just kind of capture the delta, and that's kind of only what you would be paying for. Because let's say, for example, you create a branch and then you write data to that branch as part of your test, just like we did. Let's say you do a big test and you're writing a lot of data. Well, since you haven't copied the data, like the production data, let's say the production data is, 10 gigabytes, for example, and then you add 1 gigabyte. Well, you wouldn't be charged for 11, you'd just be charged for the delta, which is also, which works very well for ephemeral environments. But yeah.
Awesome. Really complex serverless engine there. All right, so I think that's pretty much it. The last thing that I wanted to show you is that we have a new environment that's building, which is automatic, and it's coming from our GitHub workflow. So essentially, I have a new pull request here, and it's the workflows that I just showed you are creating an environment, a testing environment for me that uses the ephemeral environments, the ephemeral environments with the Neon database. So essentially, I have the same Bunnyshell YAML, the same environment YAML in this GitHub Actions environment that I have in the environment that I just showed you. It's still building, and it will probably soon be deployed. But you get the gist of it. It's pretty similar to what we have here with our environment. So that's the last step. Essentially, you can have unlimited environments here for every feature branch that you have, if you want to test something in isolation before merging the pull request, so you can catch bugs without having to merge a bunch of features into the same branch, and then you're not going to be able to see, where problems are coming from. So you have to roll back changes. Yeah, you're not going to get into that because you can test features in isolation. And that's the power of this process, is the fact that you can have realistic testing environments with production-like data with every pull request without having to merge your code. All right.